Hi everybody, and welcome to this example on functions. The example says for each graph of a function determine first of all f of 1, the domain, any x values for which f of x is 2, and the range. So I'm going to take these in order here. Here's the first example. I have this function that's just given to you by a graph. Remember, a function is any set of ordered pairs. Usually in algebra, the ordered pairs are described using an equation, but we can also just plot the ordered pairs as they've done here, and that still describes a function, a set of ordered pairs, okay, where each x is paired with only one y. So the first question here says find f of 1. Well, that means tell me the output, the y value, when the input, the x value, is 1. So I come down here, this is my x-axis, this is x equals 1. And you can see that the output, the y value there, is going to be 3. So f of 1 would equal 3 there. If I move over to this one, again the same thing. F of 1 means I want my x value to be 1 and I want to find the corresponding y value. So that would be 2 for this one. So f of 1 is equal to 2. And over here, f of 1 would equal 2. Okay? All right, part B says the domain. The domain are the x values. So notice on this first one here, I could actually list the ordered pairs. There'd be like, -4, 4, and -3, 3, and, -2, 2, and -1, 1. And anyway, if I just list all of those x values, that would be the domain. All right, now you can see that by just looking down here on the x-axis. Anywhere that there is a graph associated with it, that's in the domain. So that's like -4, -3, -2, -1. And the important point here is that there's a whole bunch of space between those integer values that's not in the domain. Okay, so here when I list the domain, I have to specifically say it's just the points -4, -3, -2, -1, 0, 1, and 2. Okay, as opposed to this example, notice that the domain, I can see that -5 is in there, and -4, and -3, but there's also all these numbers, the infinite number of numbers that are between those integral values. So I actually get all of these numbers, in this case between -5 and 2. So the domain here would be the set of x such that x is greater than or equal to -5, less than or equal to 2. In interval notation, that would be the interval that starts at -5, ends at 2, and you include those endpoints by putting the little square bracket there. Okay? Over here, the domain, again, if you just look here, look along the x-axis, and that'll tell you anywhere there's graph paired with it. So -4, -3, -2 is in there, isn't it? This little circle there means that that point is not included there, but you can see still that -2 is included here. So all of these x values from -4 to +4 are included in the domain. So that would be the set of x such that x is greater than or equal to -4, less than or equal to +4. Or again, in interval notation, that would be the interval from -4 to 4. Okay? All right. So now part C says find any values for which the output is 2, for which f of x, the y value, is 2. So in my mind, what I want to be looking at here are the y values. Where is the y value to? So notice that here, if I draw a line up here at y equals 2, you can see there's 2 x values in there. I'm going to do the same thing over here as well. Well, I got my little line maker there handy. Okay? Alright, so it's asking, what are the x values? Find the x values for which f of x is 2. You can see here, it's 2 where x is -2, and also where x is 0. Okay? Over here you can see it's 2 at -5, and also at 1. Now over here you can see it's 2 Well, it's not 2 at 0. Notice at x equals 0, right? You don't, this little circle here means that it's not equal to 2 at 0. It's actually equal to 3 at 0. But if I go just a little smidgen to the right of 0 there, like at 0.0001, that x is going to give me a y value of 2, and all of these values between 0 and 2, including 2. All right, so this would be the set of x such that x is strictly greater than 0, as long as x is bigger than 0, and at the same time less than or equal to 2. All of those x's are going to have an output, a y value of 2. All right, in interval notation, that would be the interval that starts at 0, ends at 2, includes the point 2, because if you plug in 2, you're going to get 0 because of that, or if you plug in 2, you're going to get 2 because of the closed dot there. But you don't include 0, because if you plug in 0, you actually get this 3 up there. Okay? Okay, the last thing it asks for is the range. So the range is the y value. So you just do the same thing I did down here with the yellow. Just do that in terms of the y values up here. Notice there's no y values for any of these. The only y value that's hit is this one. There's one right here. Right here, there's actually 2 x values that have that y value. Here and here. All right, so you could say there that the range is going to be, what have I got there? 1, 2, 3, and 4. That's the only y values that are in the range. Now over here, I have a whole range of y values, right? Everything from -2, -3, -2, all the way up to here. All of these y values here are going to have an ordered pair associated with it. Down at -4, there's no graph. That means there's no ordered pair that has that y value. So I would say, write this. This is the set of y such that y, it has to be greater than or equal to -3. Okay, at -3, it looks like if you plug in -2, you get -3, so I'll include that. And less than or equal to 5. Okay, so in interval notation, your interval always starts at the small number. So it starts at -3, goes to 5. And you want to include those, so it would look like that in interval notation. Now here, the range, you see that there's going to be a range value of 1 right here, and 2 right here, and 3 right here, and 4 right here, but there's nothing in between those, right? So here, again, it's sort of similar to this one. The only y values you're getting out of that are 1, 2, 3, and 4. Okay, so I hope you find that example helpful for sorting through some of these different concepts in regard to relations. See you next time.